Hi Chevelle, my name is Ryan. I don't think we've yet had the chance to interact in this course, but it was a pleasure to hear your initial thoughts on the big data and biotechnology prompt. So, starting off, I agree with your argument that the central challenge in incorporating big data and biotechnology is maintaining data quality and biological context across labs, instruments, protocol, and software systems. Your point that faster compute cannot correct bias sampling, poor documentation, or batch effects directly supports the idea that big data management sort of begins with experimental design rather than analysis. I think that your emphasis on standardization also connects with my own argument about preserving interpretive context, sort of tying back to the psychiatric research thing I mentioned in my initial post. I think that the highly standardized molecular measurements, while phenotype is reconstructed, spanning uh, different contexts, kind of creates a disconnect. So, for example, um, anhedonia may not have been documented equivalently across different DSM eras or across different interviews or interview procedures, and in that setting, placing every donor under one standardized label may create apparent consistency without true measurement of equivalence. So I kind of agree with your point on standardizing SOPs and like collection technique. Um, I would extend your position by arguing that big data pipelines need both standardization and provenance. So standardized cores should define experimental units, batch structure, all of the kind of variables and parameters, and also the primary outcomes, but the pipeline must also preserve how each clinical or biological variable was measured and adjudicated. I also agree that more data can either be an asset or a liability, and I think that's a very interesting and nuanced position you've taken. I think personally the distinction is between more measurements and more independent information. So in the sense that you can have more measurements, but you must also have them be independent. Um, Additional biological samples may improve precision and generalizability, whereas testing more genes or biomarkers may increase the number of hypotheses and the multiple testing burden. So false discovery rate control can limit false positives, but independent validation and biological effect size remain necessary. Sorry. Um, I think we kind of both converge in our argumentation, and that experimental design should drive the pipeline, and data abundance is more valuable with context. Um, and if replication and inferences remain aligned with that context and data. You also mentioned that researchers may prioritize public publications and results over reusable data. So I wanted to ask you, do you think technical reporting standards, um, do you think that technical reporting standards are enough to correct the problem, or would journals and funding agencies need to change the incentives surrounding documentation, negative results, and validation? Overall, I really liked your point, and I thought that we agreed mostly. I liked the nuance you took, or the nuance you had in your argumentation, and yeah, I look forward to hearing your thoughts as well. Thank you.